Yes, the sun rises in the east and sets in the west. What is going on behind the scenes? What causes day and night? Before we can answer that question, we have to talk about some things about Earth. So here's a cartoon picture of the globe. We're looking down at the North Pole with North America, Europe, Russia, and Greenland in view. What do the lines represent? These lines coming down from the North Pole. What are they called? All right, here we are with Google Earth. This is a depiction of the globe of Earth with all of those lines. So we have the lines that go from the top of the pole and they go all the way down to the South Pole. And then we have these horizontal lines, and some of them are named and look a little bit bolder. The long lines that go from pole to pole are called longitude lines, lines of longitude. And the horizontal lines that go like ladder rungs are called latitude lines. I want you to notice there's 3 lines of latitude that are listed. They have actual names. The one in the center of the globe, the fattest part of the globe, is called the equator. And then we have the Tropic of Cancer and the Tropic of Capricorn. We're going to talk about those later. There's one longitude line that also has a name, and that's the one that goes this way and goes down through Greenwich, England. And they just picked it because it's wherever who happened to come up with this system lived at the time. And it is called the prime meridian. I don't really have it labeled on here, but you can see that it's yellow. It's a little bit different color and thicker line than the other lines of longitude. Now when we talk about the equator, we talk about lines of latitude that are north of the equator. So anything that goes towards the North Pole is going to be north of the equator. So this is 10 degrees north, 20 degrees north, 30 degrees north. Anything that goes from the equator down to the South Pole, those lines of latitude are south. So 10 degrees south, 20 degrees south, 30 degrees south. It goes down to 90 degrees. So at the actual pole, at the South Pole, it's 90 degrees south. At the North Pole, it's 90 degrees north. So the one that would be halfway between the equator and the pole would be around 45 degrees of longitude or latitude, which is right about here. Okay, if we flip over to the North America, where we're more familiar, 45, the 45th latitude is kind of in the northern parts of the state, so like Washington State, Montana, Idaho, up in that area. So here we have the prime meridian. It's labeled this time. Anything that is west of the prime meridian, those longitude lines are listed in degrees west. So we have 10 degrees west, 20 degrees west, 30 degrees west. Anything that's to the east of that, obviously, is in east. So we have 20 degrees east, 30 degrees east. So each one of these lines on this globe is 10 degrees of movement. Okay, so why do we care? Why does it matter that we have the equator and the Tropic of Cancer and the prime meridian? Well, it's all to figure out your location. So you can pinpoint exactly where you are if you just, and see how the lines get smaller as we scroll in. Like if I wanted to know exactly where Sacramento was, I could scroll in here and I could say that it's at about, very specifically, 121 degrees 30 minutes west and 38 degrees 34 minutes north. So it is a way, the latitude and longitude lines are a way for us to pinpoint exactly where somebody is on the globe. So to recap, the longest line of latitude runs around the fattest part of the globe, and it's called the equator. All the other lines of latitude are described in terms of their distances north or south of the equator. The unit of measure is the degree, and then we can further narrow that down to minutes. So the farther from the equator, the greater the number of degrees. It is 90 degrees from the equator to either of the poles. The line of latitude circling the globe halfway up to the North Pole would therefore be 45 degrees north. Lines of longitude, so now we're talking about longitude, extend from pole to pole. Each line is measured in degrees as well, with the starting line being the one that runs through an English town called Greenwich. That's at 0 degrees longitude, and it's also called the prime meridian. You can go east or west around the planet from there. All right, so let's talk about day and night. The Earth rotates around its axis, which is an invisible line that goes from pole to pole. But it goes directly through the center of the Earth, not like the longitude lines that go around the edge. This invisible axis goes from the North Pole all the way through the center of the Earth out through the South Pole. It's invisible, it's pretend, but we think about it that way. This axis is tilted at 23.4 degrees, so it's not standing straight up and down. But we're going to discuss that in a little more detail soon. As the Earth rotates, one half is facing the sun, while the other half is facing away from the sun. The side that's facing the sun experiences day, which we see in the picture on the left, and you can see that there is this terminator line between day and night. So the sun is out over here somewhere, shining on this part of the Earth, and over on this side on the back is where the sun is not shining, and that is where it is night. And we see that over here on this page on the right. So if it's night on this side of the planet, and this looks like Africa and Saudi Arabia, what are all these lights that we see? So those are just the lights of cities. You'll see Italy's pretty lit up, and you can see where there aren't very many people, or not very much technologically advanced people anyway. In Africa, there's hardly any lights. And in parts of the big deserts over here, where there's probably nobody living, the Gobi Desert up here, and this is over by Iraq and Iran. All right, so let's go back to that word rotation. When an object turns in a circle or spins like a top, we refer to that motion as rotation. It's just the movement of something spinning around. The imaginary pole on which the object turns is called its axis. So here we have a picture of the Earth with, it looks like a toothpick through it, through the North Pole and down through the bottom, and that is the Earth's axis. So the Earth rotates on an axis that runs through its center from the North Pole to the South Pole. I'd like you to notice that this axis is tilted. It's not straight up and down. It's off to the side a little bit. That tilt is 23.4 degrees. So here's a more mathematical diagram of that. So here's the axial tilt of the Earth. If we had our orbit around the sun going off and say like on the x-axis right here, so horizontally, the vertical or perpendicular line is not where our axis is. That would be straight up and down. Our axis is tilted a little bit, and you see here's that tilt, and this angle between what would be up straight up and down and what it actually is that angle of 23.4 degrees. Here's another word that I'd like you to know, revolution. So that is the path one object takes to travel around another object. In this case, we're talking about the Earth going around the sun. Okay, the sun is the center of our solar system. This is referred to as the heliocentric model. Helio for sun, which is the Greek god of the sun, and centric for center. Sun-centered is what heliocentric really means. The Earth revolves or travels around the sun in a shape called an ellipse, which is kind of like an oval. This is also called the Earth's orbit. Each revolution, or orbit, around our sun takes 365.25 days, or 1 year. The definition of a year can be the amount of time it takes for the Earth to complete one whole revolution around the sun. Now, I know I said the Earth revolves around the sun in the shape of an ellipse, and that's true, but it's barely an ellipse. It really looks more like an actual circle. Like it would be really hard if you looked at it to see that it was oval in shape. It would look mostly circular. So when we talk about Earth's movement, there's two different things you need to know. The rotation, which is how it goes around its axis, and the revolution, which is the movement around the sun. The rotation, the Earth spins around an imaginary axis line through both poles that we refer to as the Earth's axis. This rotation is what causes day and night, and we talked about that in an earlier slide. As one side rotates and faces the sun, we get day, and as the other side is pointed away from the sun, it's in night. This line of night and day, called a terminator line, moves as the Earth rotates. The other type of movement is the Earth's revolution around the sun, also called its orbit. Every 365.25 days, the Earth makes one complete orbit or revolution of the sun, and that marks out 1 year. Do you think different planets have the same or different lengths of a year? Do they take the same or longer or shorter amounts of time to orbit the sun? All right, a couple of assignments. You're going to complete the day and night think questions that are going to be posted on Google Classroom. And then I want you to go onto fossweb.com and read The First Voyage of Columbus on the interactive ebook online. Take some time to play around with the simulations that are on the FOSS website that are available to you when you log in. There's a day and night simulation and a latitude and longitude simulation, and they might help give you some more information about those concepts if you need extra help with those.